This is an introductory video on how to handle HIPS images with the Videometer Lab software. The video will touch upon the topics: display of HIPS images, image properties, how to navigate in the right-click menu of the images, and how to do image scaling. For this video, some images of different objects have been selected. We will start by looking at an image of some sugar beets. In the header of the image is given the name of the saved image, together with a zooming value, which changes when zooming in and out. In the bottom of the image is given the band number of the currently displayed band. Next to the band number is seen the name of the band. The displayed coordinate corresponds to the exact coordinate of the pixel which is pointed at with your mouse. The value changes when you move around the image. And the value next to the coordinate is the corresponding pixel color value. In this RGB color band, the pixel color value is given in the 3 RGB values. The red button is used to indicate the number of saturated pixels in your image. Oversaturated pixel means that the pixel color value exceeded the pixel color range. For more information on saturated pixels and how to avoid these, watch the video tutorial on how to do a light setup. Holding the mouse over the button reveals a note listing which bands we find these oversaturated pixels and the corresponding amount of pixels. The saturated pixels are shown in the image indicated with red. These red marks can be turned off and on by pressing the button. If a mask has been applied to the image, this can be turned on and off in the same manner by pressing the mask icon button. For more information on how to do masking, watch the video tutorial for the training module on segmentation. In your image, there is a right-click menu listing some different options. Clicking on Properties, a new window pops up. Here all information related to the image is found. Listed is file name, size of the image in pixels, how many bands is in the image, in which format it is saved, and the pixel size. Moreover, all bands are listed together with their names, wavelength, illumination type, and information whether a filter has been used in their respective band. F1 stands for filter 1, which means no filter, and F2 is the first possible filter, and filters up until F5 is included in this image. The filter changer enabling these filters is an add-on option which can be purchased with the Videometer Lab. The default amount of bands is 19 when no filter from the filter changer or backlight is used. Under the Details tab, it is possible to add a description to the image. Furthermore, camera information, etc. is also found here. Copy to clipboard is equivalent to the Ctrl-C command. Under Zoom, one can zoom to actual size or fit the image to the window. Zooming can be done with either the mouse or the shortcut Shift and plus and minus. A foreground mask can also be enabled through the right-click menu, as seen in the video. Now we move on to how the user navigates in the bands. When viewing the image in the sRGB color band, only that single band is available under the band menu. But if one goes to view mode, a selection of different image transformation opens. The default and most used transformation is grayscale. Selecting grayscale, the amount of bands available is now 44, and the name of the displayed band also changes. The first band displayed here is taken at a wavelength of 365 nanometers. The pixel value have also changed, so that they now are displayed as a single value. A color bar can be added to the image, where the lowest pixel value in the image is displayed as black and the highest pixel values are shown as white. Now all 44 bands can be accessed through the Bands menu as seen in the video. When scrolling through the different bands, notice that the colors changes in the image and correspondingly the pixel range changes as well, as it can be seen in the color bar to the left in the image. Instead of scrolling through the bands with the menu, the shortcut for band scrolling is Ctrl, plus and minus. Now looking closer into the view mode menu. These different options are essentially just different color scales that one can apply to the images. Note that the information, and thus the pixel values, in the image does not change when applying different color transformations. When selecting inverse grayscale, as done in the video, we see that the color scale changes. White now represents the low pixel values and black the high pixel values. When scrolling through the bands, as done in the video, one sees that dependent on the band, the pixel value range changes for the same color scale. This is a very important point that the user needs to be aware of when comparing different images and bands with each other. The other possible transformation listed in the menu is cold, hot, inverse jet, and jet. Note also, when applying these, the pixel value in the images does not change, only the color scale from which the pixel is displayed changes. Under the right-click menu, there is a tab called Advanced Settings. To illustrate how these can be used, we look at yet another image of sugar beets. We now want to apply the exact same settings to the new sugar beet image as we have already done in the grayscale one. Go to Advanced and press Apply Settings to all open images. Now we see that grayscaling and the color bar is turned on in the other image, and it has also been changed to displaying band number 17. It is also possible to synchronize band shifts. Select this option on one of the images. And when scrolling through the bands in this image, the other images will follow and display the same bands. This is a quick and very useful way to comparing images and bands fast. It is also possible to rename the images under the Advanced tab. In the Window menu, it is possible to close all open images and all images except the selected one. Align all images stacks the open images on top of each other. Arrange images spreads out the images evenly on the desktop window. As we earlier applied settings to all open images, all the images have been turned into grayscale and displayed in the 23rd band, or the highest possible band in the image if not 23 bands are available. Now moving on to scaling of the images. There are two pre-made scaling options, 10% trimmed and scale 6 sigma. In the video is shown the result of scaling the image with the two different scaling methods. It is clear from the video that the two different approaches creates two very different appearing images. What actually goes on when applying scaling to the images is now explained with the use of some of the statistical features available in the Videometer Lab software. First, we start by looking at the images with no transformation and a histogram showing the distribution of pixels in the whole image. From the color bar, we see that the minimum pixel value is 0 and the maximum is 16.18. This can also be confirmed by looking at the pixel value range in the histogram. When one then applies 10% trimmed scaling to the image, this essentially means that the lowest and highest 5% pixel values are removed from the color scale. After the scaling is applied to the image, one sees that the upper and lower value in the color bar now has changed. This does not mean that the pixels outside this bound has been removed from the image. It means that the pixels in a range from 0 to 1.14 is displayed as black, and the pixels in the range from 7.52 to 16.18 is displayed as white in the image. The range in which the colors in the image is displayed has now been reduced from 16.18 to only 6.4. This means that the color contrast in the pixel range in the image has become much higher, as it is also seen in the image. The seeds seems way more detailed now after the range has been lowered. One can say that the non-important pixels have been removed from the color scaling, namely the black corners of the image and the very white saturated pixels, which is the border of the petri dish. The scaling is now reset, and we now look at the sigma 6 scale. This is a scaling that uses the standard deviation in the image. The mean in the first band of the image is given as 4.28 and the standard deviation is 2.29. This is found with the statistical software. When the sigma 6 scaling then is applied to the image, the center of the color scaling is the mean value and the scale is set to plus and minus 3 standard deviations from this mean. This is reflected from the color bar in the left of the image. The range of this scaling now goes from minus 2.62 to 11.18, which is a total range of 13.8. From the image, it is clear that this scaling does not create the same amount of contrast in the seeds as it was seen for the 10% trimmed scaling. These scalings can also be done more manually from the settings option. Here, the center and the width of the scaling can be changed with the two top bars. Stretch between min and max is the default scaling that is applied to all new images. It is possible to stretch the scaling between a fixed value range. Then the scaling to a fixed percentile range is essentially the same as 10% trimmed when the scale is chosen from 5 to 95. And mean plus and minus standard deviation is equivalent to sigma 6 scale, with the possibility to change the amount of standard deviation used. The most important take-home messages when it comes to scaling is: the scaling is used to create the most contrast in the main objects in the image, in this video, the sugar beets. And scaling is also just a visual color transformation used to visualize features in the images by contrast. The image data and pixel values itself does not change.